imagine this. So you're an astronaut and one day you decide to take a relaxing walk in space. Everything is perfectly fine until suddenly the line connecting you to the spaceship breaks. Now this is just not a very good scenario because in exactly 20 minutes both you and the spaceship will hit the atmosphere and burn up like gasoline. What can you do to save yourself? Will you A. swim, or B. use advanced physics to save your life? The right answer is not A, because in the universe there is no air to push yourself forward on if you try to swim. Luckily, we know our physics and we're going to use some of Newton's laws to solve this.
She told him she'd rather fix her makeup than try to fix what's going on.
Newton's third law tells us that forces always appear in pairs. It can be compared to, for instance, when you swim, you push water backwards and the water pushes you forwards. Or a bird that flies, it pushes air backwards and the bird travels forwards. However, like we already said, in the universe there is really nothing to push yourself forward on. And that is why you need to have an object that you will throw in the opposite direction of where you want to go. And lucky for you, you just happen to have an object, because when you went out of the spaceship, you brought a screwdriver with you. Smart. Now it's very exciting because you are in the universe and you have your object and you know that you need to use Newton's third law. So you need to throw that object away from you. Now this is very important. Do not literally throw it, because it will have much better effect if you use it as a sort of wall to just push yourself backwards on. And another important thing, when you practice this in your living room before going to space, be careful not to break anything. So now that you have pushed the object away from you, both you and the spaceship and the screwdriver will be in sort of a free fall. This is you, and you have now thrown the screwdriver away from you, and that means you are heading towards your spaceship, like we said, according to Newton's third law. Now you would want to know a few details about this entire situation to manage to calculate if you will make it to the ship in 20 minutes. And like we said, it's very important that you make it within 20 minutes, because after those 20 minutes your ship will crash into the atmosphere. So you need to make it by then. And the details you would want to know is, first of all, your mass. Now I would assume that your mass with the spacesuit, everything, is approximately 100 kilos. Yeah, we could just say that. So the mass would equal 100 kilos. The mass of the screwdriver is around 0.5 kilos. And also the distance to the spaceship would be, I would say, around 30 meters. We could say that. So the distance here is 30 meters. And also the power with which you threw the screwdriver away from you, we could say that that power equals to 10 newtons. And we could also say that the time you used to throw the screwdriver away equals 0.30 seconds. So the force would equal 10 Newton, and the time you used to throw the screwdriver away would be 0. So the time would equal 0.30 seconds. Now the first law you would want to apply to this situation is Newton's second law. And this is because, well, Newton's second law states that force equals mass times acceleration. And like I said, this situation can be compared to a free fall. And in a free fall, acceleration is central. And we also need to know the acceleration later when we're going to calculate how fast you are heading towards the spaceship. So if we just turn this formula around, we get that acceleration equals force divided by mass. And then we just put in the right numbers. So that means that acceleration will equal, as you see here, the force is 10 newtons because you threw the screwdriver away with you with a force of 10 newtons. So it's 10 newtons divided by your mass, and your mass here is 100 kilos. So it's 10 newtons divided by 100 kilos, and that equals 0.10. So that means that acceleration would equal 0.10. It is now time to calculate how fast we are heading towards the spaceship, because then we can know if we made it in time. That is where we introduce velocity. Velocity, which in a way could indicate your speed. So velocity equals acceleration times time. And so we just put in the right numbers once again. So velocity equals, as you see here, acceleration is 0.10. So it's 0.10 times the time in which you used to throw the screwdriver away, which was 0.30 seconds. And we get that velocity equals 0.030 meters per second. So velocity equals 0.030 meters per second. And now you need to check how far you will make it in 20 minutes, because like we said, 20 minutes is the time you have to get back to the spaceship before you hit the atmosphere. So then we need to see how far you made it. And that means that stretch, which is how far you made it, it equals velocity times time. So it's velocity, and this is another thing. The time we are going to use now is not the time in which you used to throw the screwdriver away. What we need to check is if you will make it in the time that you need to make it in to get back to the ship, which is 20 minutes. So basically we're going to check how far we will go in 20 minutes. And if that is over 30 meters, then we will be fine, because there are 30 meters back to the spaceship. But if it's under 30 meters, then we won't make it in time. So velocity times time, and like I said, the time here will be the 20 minutes. I'm trying to mark it here so you see. So once again, just put in the right numbers, and velocity is 0.030 meters per second. This times the time, which is 20 minutes. Once again, the time we need to get back to the spaceship. And we need those 20 minutes in seconds. So we're going to take 20 minutes times 60. And this all shows that the stretch, so how far we made it, was 36 meters. And that's really good, because 36 meters is more than 30 meters, which means we made it back to the ship. Yes, 36, more than 30. Yay, we made it. So to sum this up, this was basically an example of how to apply physics in everyday life, or when you're going to space. In the end, we can just ask ourselves, what if there were two astronauts out there and they didn't have anything to throw?